Okay, so why don't you take a second to try and do this problem, and then after you have attempted to do the problem, continue the video, and then let's see if we can work on it together. Okay? Great. Alright, so now let's continue. So, this is actually a really tough problem in GRE 85% of people that took this got this wrong. And it's a probability problem. So let's go through it and see what we can do. Alright, so it says 20, so this is problem 24, of the 20 light bulbs in a box, 2 are defective. So you have a box of some sort. Ignore my poor box drawing skills. But in there, you've got 20 light bulbs. Call it LP. Of those, 18 of those light bulbs are good. And 2 of them are bad. Alright, it says an inspector will select 2 light bulbs simultaneously and at random from the box. And it wants to know what is the probability that neither of the light bulbs you've selected will be defective. Okay, and it wants to give your answer as a fraction. So it's asking for some sort of fraction. I'll leave the fraction here, and we'll fill it in as we go. So it wants a probability that neither of the light bulbs are defective. So it wants probability that you choose 2. And that you get 2 good ones. Or as they say it, they say 0 bad ones. But I think it's actually a lot easier to look at this if you see 2 good ones. I think that's the first thing that that I would change. I would say this says neither of them are defective, which means both of them are good. Right? And so this is a probability question. It's and the basic understanding of probability, which is what I'm going to go back to for this problem, is at the bottom of your probability, you want the total number of possible outcomes in an event. So the total number of possible outcomes you can get when you choose 2 light bulbs. Okay, so in words, what we're doing is we are choosing 2 out of 20. Now, when you're choosing 2 out of 20, and if you look at the problem, you think about it, order doesn't really matter. That means you're doing what's called a combination problem. Or what we're going to say is we're going to do 2 choose, or sorry, we're going to do 20 choose 2. Alright, so that is the total number of possible outcomes that you can have in this event. This is just a basic notation for what's called a choosing problem. These are some of the ways of saying it. This is n choose k, or n choose k. And this is just a shorthand way of talking about the number of possible things that can happen when you choose a subset out of a larger set of items. And the formula for this is actually specifically like this. Alright, so this is your formula. I forgot an exclamation mark there. And this is n factorial over k factorial n minus k factorial. Alright, so what is a factorial? A factorial is pretty simple. A factorial is just if you got something like 4 factorial, all you're doing here is you're just turning this into 4 times 3 times 2 times 1. Alright, you're just taking the number and you're deleting, or you're multiplying by 1 lower every single time until you get to 1. Alright, so 5 factorial will be 5 times 4 times 3 times 2 times 1. And so on and so forth. So that's what a factorial is. Alright, and that's what that formula down here means. That is n factorial over k factorial, n minus k factorial. Maybe I will just very quickly write that a little better, because that's actually a pretty important aspect. So I'll write that just a little better so it makes a little more sense. It's more clear for those who are watching. K factorial. Alright, yeah, maybe a little better. You get it. Okay, so we have done 20 choose 2. This is the total number of possible outcomes in this event. Alright, and that's when you have 20 light bulbs and you choose 2 of them, 2 of the 20 light bulbs. Now we want to know, what are at the top of any probability like this, you've got the total number of outcomes at the bottom, and you have the total number of solutions at the top, or the total number of good outcomes that you're looking for. That goes up at the top. Okay, so what are we looking for? We're looking for 2 good ones. Well, how many different ways are there that we can choose 2 good light bulbs out of a situation where we have 18 good ones and 20 bad ones? Well, it's actually going to be the number of situations where we choose 2 of the 18 good light bulbs. So what we're looking for is we're choosing out of the 18 good light bulbs 2 of them. Right, that goes on top. All right, this is the total number of potential solutions. This is the total number of potential outcomes. All right, and this is what we're going to be solving for. All right, so we'll solve that. We'll solve for that right up in here. We're going to use this formula down here. So let's start with this one here. This is going to be, we're going to apply this formula right here. All right, and remember, n is on this side, k is on this side, so it follows suit like this. So 18 is going to be our n, and 2 is going to be our k. All right, so that's what we're going to be doing. So we get 18 factorial over 2 factorial 18 minus 2 factorial. Okay, so that is our formula. Now what we do here is this turns into 2 factorial 16 factorial. Right, that's just 18 minus 2. And then here we're going to break up this 18 factorial into its first two components, 18 times 17 times 16 factorial. Right, because normally it would be 18 times 16 times 15 all the way down. What we can actually write this as is 18 times 17 times and then 16 all the way down, or 16 factorial. Right, now that we've written it like this, and we know that both of these are multiplying, every single thing here is being multiplied, we can cancel the 16 factorial here and the 16 factorial there. That leaves us with 18 times 17 over 2 factorial is 2 times 1, which is just 2. All right, now what is that? Well, let's get our calculator out really quick. All right, so we're looking at 18 times 17, 306, divide that by 2, and we're getting 153. All right, so that is going to be 153. All right, so now in our fraction over here, we're looking at the top, which is 18 choose 2, being 153. All right, that is the top number. And I may not have said this at the very beginning, but that is what they're looking for. They want us to write our answer as a fraction. Say that right here. Give your answer as a fraction. So that is what we're going to be doing. All right, so now let's do the bottom. So we found the bottom. We found the top. Now we want the bottom. The top was the number of potential good solutions that can happen, and that is 18 choose 2. Now, what are the total number of outcomes? Well, you're choosing 2 out of the total set of 20, so it's 20 choose 2. All right, so now let's write that one out. Again, we're going to use this formula. This is going to be our n, and this is going to be our k. So then we get 20 factorial over 2 factorial 20 minus 2 factorial. Okay, so that is the next formula for us to solve. This is going to be 2 factorial multiplied by 20 minus 2 is 18 factorial. And then what we're going to do is we're going to break up 20 factorial into 20 times 19 times 18 factorial. Right, so this is the same thing as this. 20 factorial is the same thing as 20 times 19 times 18 factorial. And that's why we're able to do that. All right, so now that we know that, again, everything here is multiplication, we can cancel out our 18 factorials, which is going to leave us with 20, oh, that's 12, I don't know why I did that, 20 times 19 divided by 2, which equals, let's do that really quick on our calculator, 20 times 19 equals 380 divided by 2 equals 190. All right, so now we're sitting at 190 as our bottom choice. That was us figuring out this number right here, and the number down there is 190. All right, so when you're picking 2 light bulbs out of a box that has 18 good ones and 2 bad ones, the total number of good light bulbs, the total number of times that you can, or the total number of solutions, or the total number of situations where you pick 2 good light bulbs is the same thing as the total number of times that you choose 2 of the 18 good light bulbs. Your total potential outcomes, because there are 2 bad ones, is going to be you can choose any 2 of the 20, so it's 20 choose 2. And when you calculate that out using factorial notation, using this n choose k formula, you get 153 over 190, and that is the answer to the problem.